NuSTAR, NuSTAR, NuSTAR Nuclear Spectroscopic Telescope Array, also named Explorer 93, and SME-X-11 is a NASA space-based X-ray telescope that uses a conical approximation to a Wolter telescope to focus high-energy X-rays from astrophysical sources, especially for nuclear spectroscopy, and operates in the range of 3 to 79 keV. It was successfully launched on 13 June 2012, having previously been delayed from 21 March 2012 due to software issues with the launch vehicle. The mission's primary scientific goals are to conduct a deep survey for black holes a billion times more massive than the Sun, to investigate how particles are accelerated to very high energy in active galaxies, and to understand how the elements are created in the explosions of massive stars by imaging the remains, which are called supernova remnants. Having completed a 2-year primary mission, NuSTAR is in its 9th year of operation. History. NuSTAR's predecessor, the High Energy Focusing Telescope, HEFT, was a balloon-borne version that carried telescopes and detectors constructed using similar technologies. In February 2003, NASA issued an Explorer program, Announcement of Opportunity OWL. In response, NuSTAR was submitted to NASA in May 2003 as one of 36 mission proposals vying to be the 10th and 11th Small Explorer missions. In November 2003, NASA selected NuSTAR and 4 other proposals for a 5-month implementation feasibility study. In January 2005, the program was canceled in February 2006 as a result of cuts to science in NASA's 2007 budget. On 21 September 2007, it was announced that the program had been restarted, with an expected launch in August 2011, though this was later delayed to June 2012. The principal investigator is Fiona A. Harrison of the California Institute of Technology, Caltech. Other major partners include the Jet Propulsion Laboratory JPL, University of California, Berkeley, Technical University of Denmark DTU, Columbia University, Goddard Space Flight Center GSFC, Stanford University, University of California, Santa Cruz, Sonoma State University, Lawrence Livermore National Laboratory. NuSTAR's major industrial partners include Orbital Sciences Corporation and ATK Space Components. Launch. NASA contracted with Orbital Sciences Corporation to launch NuSTAR mass 350 kg 770 lb on a Pegasus XL launch vehicle on 21 March 2012. It had earlier been planned for 15 August 2011, 3 February 2012, 16 March 2012, and 14 March 2012. After a launch meeting on 15 March 2012, the launch was pushed further back to allow time to review flight software used by the launch vehicle's flight computer. The launch was conducted successfully at 16:37 UTC on 13 June 2012, about 117 mi 188 km south of Kwajalein Atoll. The Pegasus launch vehicle was dropped from the Elminus 1011 Stargazer aircraft. On 22 June 2012, it was confirmed that the TENM-33FT mast was fully deployed. Optics. 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 Unlike visible light telescopes, which employ mirrors or lenses working with normal incidence, NuSTAR has to employ grazing incidence optics to be able to focus X-rays. For this conical approximation Wolter telescope design optics with 10.15 mm 33.3 ft focal length are held at the end of a long deployable mast. A laser metrology system is used to determine the exact relative positions of the optics and the focal plane at all times, so that each detected photon can be mapped back to the correct point on the sky even if the optics and the focal plane move relative to one another during an exposure. Each focusing optic consists of 133 concentric shells. One particular innovation enabling NuSTAR is that these shells are coated with depth-graded multilayers alternating atomically thin layers of a high-density and low-density material, with NuSTAR's choice of PT/CC and W/C multilayers. This enables reflectivity up to 79 keV, the platinum K-edge energy. The optics were produced at Goddard Space Flight Center by heating thin 210 mm 0.83 in sheets of flexible glass in an oven. The coatings were applied by a group at the Danish Technical University. The shells were then assembled at the Nevis laboratories of Columbia University using graphite spacer's machine to constrain the glass to the conical shape and held together by epoxy. There are 4,680 mirror segments in total. The 65 inner shells each comprised 6 segments, and the 65 outer shells 12. There are upper and lower segments to each shell, and there are 2 telescopes. There are 5 spacers per segment. Since the epoxy takes 24 hours to cure, 1 shell is assembled per day. It took 4 months to build up 1 optic. The expected point spread function for the flight mirrors is 43 arcseconds, giving a spot size of about 2 mm at the focal plane. This is unprecedentedly good resolution for focusing hard X-ray optics, though it is about 100 times worse than the best resolution achieved at longer wavelengths by the Chandra X-ray Observatory. Detectors. Major scientific results. NuSTAR has demonstrated its versatility, opening the way to many new discoveries in a wide variety of areas of astrophysical research since its launch. Spin measurement of a supermassive black hole. In February 2013, NASA revealed that NuSTAR, along with the XMM-Newton Space Observatory, has measured the spin rate of the supermassive black hole at the center of the galaxy NGC 1365. Tracing radioactivity in a supernova remnant. One of NuSTAR's main goals is to characterize stars' explosions by mapping the radioactive material in a supernova remnant. The NuSTAR map of Cassiopeia shows the titanium-44 isotope concentrated in clumps at the remnant's center and points to a possible solution to the mystery of how the star exploded. When researchers simulate supernova blasts with computers, as a massive star dies and collapses, the main shock wave often stalls, and the star fails to shatter. The latest findings strongly suggest the exploding star literally sloshed around, re-energizing the stalled shock wave and allowing the star to finally blast off its outer layers. Nearby supermassive black holes. In January 2017, researchers from Durham University and the University of Southampton, leading a coalition of agencies using NuSTAR data, announced the discovery of supermassive black holes at the center of nearby galaxies in GC 1448 and IC 3639.